Solving rational equations. So rational equations are equations that contain fractions. Usually they have variables in the denominator. Now, a few steps to take for solving rational equations. First, you always want to check if your denominator needs to be factored. In example 1, we do not need to use any factoring. Just want to, work out a simple equation with fractions in it. So the first is to see if you have to factor the denominator. In this case, as I said, we do not have to. Now the next step will be to find the least common denominator. So you want to look at all your denominators. Least common denominator. So we have 2, 3, and 4. So the least common denominator between 2, 3, and 4 will be 12. 12 divided by 2, 12 divided by 3, and 12 divided by 4. So I'm going to multiply each top and bottom by what is missing to be 12. So 2 times what gives you 12? 2 times 6. Oops, there. Here I'm going to do 3 times 4. Here I'm going to do 4 times 3. Once I have done that, I'm going to go ahead and rewrite. So I have 6 over 12x plus 4 over 12 equals 3 over 12x. Now the denominator is the same, so I can go ahead and cancel it. So now I have 6x plus 4 equals 3x. Go ahead and combine like terms. So I have 4 equals negative 3x divided by negative 3. X equals 4 over 3. So we found the least common denominator. Multiply each top and bottom by what is missing to be the LCD, the least common denominator. And once we have all denominators the same, we go ahead and cancel it and simply solve the equation. Let's see more examples. So here we need to first start by checking if we need to factor the denominator, and we do not need to factor the denominator. I will let you know when we need to so you can see the differences. So we go to the next step is to find the least common denominator. In this case, the least common denominator is going to be, so we have 5x and 3. So we're going to say 3 times 5 is going to give me 15, and then I need to have the x as well because it's in the denominator. So then 15 times what? 5 times what gives me 15? X times 3x. Oops. X times what gives me 15x times 15. Top and bottom. 3 times y gives me 15x, 5x. Oops. Now I'm going to go ahead and rewrite. So I have at the top, 9x over 15x plus 15 over 15x equals 10x over 15x. Now that all the numbers are the same, I can go ahead and cancel it. So I'm left with 9x plus 15 equals 10x. Again, we're solving for the variable. So we have 15 equals 1x, which is 15. Now, because we have a variable in the denominator, we need to check to see if x equals 15 is good. Meaning if it's a valid solution, because if I substitute 15 for x in the denominator, does it make it equal to 0? And it does not, because it's 1 over 15, that's just a number. But it's something you have to check. You always want to check, okay? So it would have looked like this. Well, this is not 0, so we're good. All right. Let's see more examples. So we have 3 over y plus 4 over 3 equals negative 1. Again, now need to factor in this case. The least common denominator is, let's put this over 1. So y times 3 gives you 3y times 1 is just 3y. So my least common denominator is 3y. So now I need to multiply each top and bottom by what is missing to be the least common denominator. So in this case, I'm going to multiply by 3. And in this case, I'm going to multiply by y. And here I'm going to multiply by 3y. I rewrite. So I have 9 over 3y plus 4y over 3y equals negative 3y over 3y. Again, once my denominator is the same, we cancel that. So I have 9 plus 4y equals negative 3y. Need to combine like terms. So I have 9 equals negative 7y. Divide both sides by negative 7 in order to solve for y. So I am left with 9. Y equals negative 9 over 7. And if I were to substitute that in the denominator for the first term, it will not be equal to 0. So this is a good answer. Okay. Let's see more examples. So I'm going to go ahead and put this over 1 here. And then we need to check if we have to factor the denominator. In this case, we do not. My least common denominator is going to be x plus 1. I need to multiply each top and bottom by what is missing to be x plus 1, which is just this factor right here. Top and bottom by x plus 1. So then I'm going to go ahead and rewrite that. So I have 3 times x plus 1 over x plus 1 minus 6x over x plus 1 equals 6 over x plus 1. Again, since it's an equation, when the denominator is the same, we go ahead and cross it out. So now at the top, we're going to have 3x plus 3 minus 6x equals 6. We're going to go ahead and combine like terms. So we have negative 3x plus 3 equals 6. Like terms being 3x and negative 6x. Minus the 3x on both sides. Divide both sides by negative 3. I get negative 1. Now we must check if the answer is valid or invalid. If I substitute negative 1 in the denominator, would it equal to 0? Let's see. Would the denominator equal to 0? Oops. So I'm going to substitute negative 1. I do believe this is going to be 0 and this is going to be 0. So negative 1 is your answer, but it's not a valid answer, because it will turn the denominator equal to 0. So that's something that you have to always check, especially when you have things like this. All right, let's see another example. Oh, right here. We're going to start the same like the previous example, over 1. And we're going to check for our least common denominator. Which, what do I have there? Okay. Least common denominator in this case, x plus 2. So I'm going to multiply by x plus 2, what is missing. So now I have 5 times x plus 2 over x plus 2 minus 8 over x plus 2 equals 4x over x plus 2. Because it's an equation, right? Once we have all denominators the same, we can go ahead and cancel it out. Okay, so I am left with 5x plus 10 minus 8 equals 4x. Okay, combine like terms. 10 minus 8 gives me plus 2. Minus the 5x to both sides. This gives me negative 1x. Divide both sides by negative 1. And I believe we have encountered, negative 1, negative 1, negative 1, another scenario. The same, right? Negative 2. If you check, not valid. The denominator will turn to 0 as well. Okay? Let's see more examples. So here we're going to start the same way. Put this over 1. I look at all my denominators and I cannot factor. So I need to find my least common denominator. And you want everything from the denominator. So I'm going to pick the variable with the highest exponent, which is x squared. So this one is missing an x squared. This one is missing an x. So once I multiply that, I'm going to have x squared plus 3x equals 28 over x squared over x squared over x squared. Cancel the denominator. So now I have x squared plus 3x equals 28. We need to solve for x, but the moment we have that square, so it becomes a quadratic, we need to set it equal to 0. All right, I'm going to go ahead and write the work right here. Plus 3x minus 28 equal to 0. So now we have to factor this. Factors of 28 that will subtract to 3, I think is 4 and 7. Plus 7. Plus 7 minus 4. We have to set both of them equal to 0 and solve for the two linear equations. Gives you that. So if you were to substitute the negative 7 in the denominator, it will not make it equal to 0. If you were to substitute the 4 in the denominator, it will not make it equal to 0. So both are valid solutions. Alright, valid answers. We factor here using the AC method. Okay. Again, factors of 28 that will subtract to 3. Let's see here. We're going to start by putting this over 1. And we got a factor using difference of squares. Alright. Once you do that, you're going to have 36 over x plus 3, x minus 3 equals 2x over x plus 3 minus 1 over 1. The least common denominator is everything that's in the denominator without being repeated. So x plus 3, x minus 3. So this side is missing the x minus 3. This side is missing everything. X plus 3, x minus 3, x plus 3, x minus 3. Alright. Now I am running out of space, so what I'm going to do is, from this moment, since they're all going to have the same denominator, I'm going to go ahead and cancel it out. So now I have left with 36 equals 2x times x minus 3 minus, this is going to give me the x squared, put it in parentheses. Well, let's not skip that many steps. Minus x plus 3, x minus 3. All right, so let's simplify. I have 36 equals 2x squared minus 6x minus, this is going to give me x squared minus 9. So it's going to be negative x squared plus 9. Okay? I'm going to go ahead and combine like terms. Those are in the same side of the equal sign. 36 equals 2x squared minus x squared gives you 1x squared minus 6x plus 9 minus the 36. It's going to be 0 equals x squared minus 6x. And what is that? 27? 27. So we have to factor again. Okay, factors of 27 that subtract, that add to 6. Ooh, factors of 27 that add to 6. Let's see. 27. Oh, why is it like that? No, it's this. Okay, factors of 27. 1 times 27. 3 times 9. We must have made a sign mistake. Where did we make a sign mistake? Let's see. Because we need this 6 to be positive and this 7 to be negative. Oh, right here. Ooh, found the mistake. Right here. See? 9 minus 36. That should be negative 27. Hopefully you guys will notice when you are watching this. Right, negative. So now my signs are going to be, oof, my pencil dropped. Oh, excuse me, my bad. Right here, oof. Okay, it's going to be minus. Okay, now my pencil don't want to write. 1 sec. Pencil seems to have lost connection from the iPad. Maybe it's dead. Imagine if it's dead. Oh my goodness. Okay, so we need to finish this problem. Okay, this is not gonna work. Let's see. Let's use my finger. Minus. Oh my goodness, this is gonna take forever with my finger. I'm gonna erase it here because I'm gonna need more space with my huge fingers. We're gonna have x minus plus 9 3, and this is both equal to 0, so then we have x minus 9 0, x plus 3 0. So this gives you x equals 9, x equals negative 3. And then which one, if we go to check, we gotta check. You have to check. Check. If you check, we have the 9 and the negative 3. If we take 9, let's see, use a different color for this. If we take 9 and substitute here, we're gonna have 36 minus 9. And then if we substitute here, we're gonna have 9 plus 3. Both are not gonna give you 0. So the 9 is good. Check. However, if we put the 9 here, the 3 here, in this one, it's going to be negative 3 plus 3, 0. So that's undefined. And if we put it here, we're going to have negative 3 squared gives you positive 9 minus 9, 0. So this one is not valid. All right? Not valid. The negative 3. Okay, so I have another example, but we're going to leave it to this one until I charge my pencil.